Welcome to Lagos State University, Lagos, Nigeria, the Science and Technology Education Research Group. We are on lesson 31 and we'll be looking at how to conduct path analysis using AMOS. I'm Peter Okebukola, the facilitator. Let us begin with a review of the lesson we had last, lesson 30, which is on using multiple regression in path analysis. Okay, Dr. Sonny et al. How far with your assignment on path analysis?
Thank you very much, sir. I completed my own yesterday. I emailed to you last night, and I've got copies here for our colleagues.
Yeah, how about the others?
Yes.
Okay, fine. So you're all set. Now let's go and review the assignments in my office. So let's go.
Okay, sir. Thank you, sir.
Let us see your assignments, but I think before that, we need to have a feel of the general principles of path analysis. So who can share with us these general principles? Maybe Dr. Michael Hove, just back from Ghana. So share with us what these general principles
Thank
are.
you very much, sir. There are two basic principles. The first step is to have an hypothesized model. The researcher must hypothesize the model. First, you should have a dependent variable and could link to an independent variable, another independent variable, and the third independent variable, which is indirectly related. After this, you have to run a series of multiple regression analysis on the data that he has here, and then you will now come up with the final model. The final model will show the relationship between the dependent variable and the independent variable, showing the beta value. For instance, you have the value of 0.77, 0.84, and you could have a 0.22, and here is a value of 0.15. This is the final model that shows the relationship between the hypothesized model and the final model.
Well, is it right? Are those the general principles?
Yes,
Yeah, I think I think you have done very well. Right. Okay. Let's let me put on my cap like you others have. We will now review your assignments after listening to the general principles. So let's begin with Dr. Sonny. Can you flag off?
Yes, sir. Thank you very much, sir. I emailed to you yesterday.
Yes. I got it. Copy.
On page 1, to begin with, I ran an hypothesized model was presented on page 1, and you can see that after that, I ran series of multiple regression on the data collected based on the variables. The result of multiple regression is there on page 3, as you can see. I then got the final model on page 2. The final model is showing that resource availability is the most potent variable of all the independent variables. It's the most potent that affects teacher performance, the dependent variable. The beta value is 0.42, as you can see there.
Wonderful. Well done, Dr. Sonny. I can see you have a wonderful final path model there. Let's hear from our lady, Dr. Olaniyo.
Thank you,
So
sir.
what did you?
Here is mine, sir. Here is my hypothesized model, and I ran series of multiple regression as presented here. Okay, and the final model showed a direct linkage between PCK and teacher performance with a beta weight of 0.25, sir.
Okay, that's very good. I think you've all done very well, and that will. We have analyzed or drawn a path models using multiple regression analysis. Now there is an alternative way of doing it using another software. It's an SPSS software called AMOS.
AMOS?
Yeah. AMOS, yes, AMOS.
Is that supposed to be somebody's name?
Yes, that's my name. Yeah, I'm joking. Now, in statistics, you have what you call moments. Moments. And then moments, the structures of moments. So this software, this program is analysis of moment structures, which is AMOS, analysis of moment structures. And that's what we want to learn today. So, what are we going to be doing in this lesson? What are our lesson objectives? 4 of them. First, we're going to be explaining what AMOS is. Rita was asking about Mr. Amos, so we're going to be explaining what it is. And then we'll give examples of research where AMOS can be used in education, in social sciences, in science, and other disciplines. And then we'll highlight the main features of AMOS. And very importantly, this lesson will look at a practical example of how to use AMOS for path analysis. So what is AMOS? AMOS is a short form, if you like, an acronym for analysis of moment structures. As you can see, the A is derived from analysis, the MO is from moment, and the structures takes the S, AMOS. Well, AMOS is a very easy to use program for structural equation modeling. I mean, you make some visual representation based on the models. What do you do with it? Just like using multiple regression analysis, as we learned by way of the examples that Dr. Sonia and the others gave, is you specify the hypothesized model. Well, I think Ahove also mentioned it. Specify the hypothesized model, and very quickly, AMOS performs the computations, and it will display your results, the final path model. So when can we use AMOS? Well, we use it anytime for any study that will demand our exploring relationships, and where we have to draw paths among a set of variables. So when you see a study that will demand that you will explore relationships and draw paths, AMOS is there to help you out. Let's look at a number of examples in education and social sciences where AMOS can be applied. We have given 4 examples here. One is a path analysis to identify factors influencing students' achievement in physics. The second one is also path analysis. So you will get a feel that you are looking at the structural equation modeling, visual analysis, and so it's path analysis that you'll see reflect in most of the titles of the studies. Using path analysis to understand the perception of school principals of effective teachers. 2 more. School dropouts, a path analytic assessment of causal factors. And then the last example we're giving here, which is in social sciences, testing a model of governance among state governors, a path analytic study. What about in science? Path analysis of the changes in polycyclic aromatic hydrocarbons in some locally consumed smoked fish products in Lagos, Nigeria. And the other example is a causal model explaining consumer preferences of varieties of smoked fish in Nigeria. So path analysis, anytime you're doing path analysis, AMOS is there to do it more effectively and visually more appealing. Now, what are the main features of AMOS? Well, it provides a lot of methods within the structural equation model, and we have listed a number of them here. Don't be bothered about, because some of them may sound highfalutin, to the mathophobics. Mathophobic now people who do not like maths. Maximum likelihood, unweighted least squares, and all of these that you can see here. So it provides these features, these methods. At the background, you don't need to be bothered about this, and it will do all of this at the background for you. Enough of the talk. Now let's move on to the practical. Let's see AMOS in action. Yes, so let's have a practical session on the use of AMOS. What are the steps involved? For me, I can see 7. The first is for us to load the data to AMOS. The second is to draw the hypothesized paths and come up with a diagram. The third is for us to set the parameters for the analysis, and then we conduct the analysis. AMOS will draw the final path, and then we interpret the path diagram and copy and paste into our research. Yeah, let us implement the steps with a study. The study is entitled Exploring Causal Links Among Variables Impacting the Performance of Lagos State Secondary School Teachers. I've actually derived this from one of our group members, Dr. Akintoye. So how did we conduct the study? It was a survey, and we had 20 teachers from a stratified random sample, and we collected data using a string of instruments on content knowledge, pedagogic content knowledge, sex, welfare, availability of resources, and teachers' performance. So we now have all this data to plug into So let's have a feel of the data. We've gone out there to the field to collect data on all of these variables, and we have entered the data in. So here we are with the data. We want to see how these variables impact on the performance of teachers. So we collected data, as I said, on content knowledge, on pedagogic knowledge, on pedagogic content knowledge, on sex welfare, and all of that. So we will now transfer this data to SPSS, where we will save it before exporting to AMOS. You will recall that the process is quite simple. We highlight this, we copy, and then we'll take to SPSS. We're launching SPSS now, and SPSS has loaded. We cancel this. This variable view, we go to data view, and what we do, we paste. You right click, and then we'll paste the data that will enter the word. Now we have 1, 2, 3, 4, as you can see, 7 variables. This variable 7, you know, is the teacher performance that we are looking at how these other variables link up with it. So what we want to do now is to go to the variable view, and as we notice, the first variable here is content knowledge. We then change this to content knowledge. We'll make it CT for content knowledge, because the variable name will go for maximum of 8 characters. So the second one is pedagogic knowledge. Let us put that as PK, and then we'll keep going until we get to the last one, which is teacher performance, which we can abbreviate as TP. So we got all the 8 variables all set. Next thing to do is to save this data in SPSS. We'll go to save, and we look for the appropriate location where we want to save it. For me, I'm moving on there. So I've got a location for it, and I want to call it sample 2. And of course, it's automatically saved by SPSS as .sav file. So we can see it's keeping 7 of the 7 variables. Then it says save. So that done with SPSS for getting the data saved. We'll now go to SPSS AMOS. We launch SPSS AMOS. You can see it's coming up. When AMOS has loaded, this is what you have. You have this canvas, this area where you do all your drawings. And then you have this toolbar section. It's very easy to navigate because you have what each of these buttons do indicated when you run your mouse over it. You can see this one is draw observed variables. What is this one? Yeah, I'm sure you can read it. This is that. And this one is move objects. This is select data files. So first thing to do, as we indicated earlier, is for us to load the data. Now let's look for, you can just keep scrolling and you see this one is select data file. So you click on this and it comes with this dialog box and you begin to look for the file. File name, where are you? So we'll go to where it is. You can see it's sample 2. So you click on this and it's already loaded. So we'll say okay. Step 1 gone. Step 2 is for us to draw the hypothetical data. Recall that there are 7 variables. So this one is draw observed variables. We have observed 7 variables. So you click on this and you begin to draw. Now let's have a box for one of the variables. Now we want this box to be the same as the others. So if you look at this, you find that it is duplicate objects. So if you click on this and you come here, you can then draw this one down here. Yeah, so how many of these boxes do you think we should produce? Yeah, you're right, 7. So this is 3. So you just hold on to this on the red mark shows, the red outline shows 4. Since we're going to have teacher performance here, so that's 5. How many more to go? 2. Let's get another one here, and let's get another one here. Good news is that we can easily move this around. You can see this one. This is to move the object. So you can move this object. You can move them anywhere you want on this this part of the screen. Now, if you want to delete any of this, you can see this scissors, erase objects. So you click on this and you come. When you see the red mark show up, it goes off. So now let's duplicate this again. So it's as easy as that. So having laid out all our boxes, we now need to write the names here. The interesting thing for AMOS is that you can you get the names from the variables, that you can say list variables in data set. So you click on this icon and you find the 7 variables that we have listed here. In pressing or attaching the names to these boxes, all you need to do is to drag. You know, we said this will be what? Yeah, you're right, teacher performance. So you drag this one here. So you can see teacher performance. Now let's put content knowledge here. We can put pedagogic content knowledge about there. That's pedagogic knowledge, excuse me. Pedagogic content knowledge may be here. Sex may be here. Welfare here. Resources here. Okay, let's close this one. Now, you can move any of this around. As we said, you can move this one here. You can just navigate. Now, the next thing to do is, of course, to connect by way of arrows. There are 2 of these. There are 2 types. The draw path single-headed arrows. As you can see, this one is draw covariances, double-headed arrows. No, I don't want to. So let's begin by drawing. You click on the arrow, and then from content knowledge, we say, yeah, let's hypothesize a direct link. You will notice that as soon as you click on this first box, it shows a red mark, and the box that's accepting it comes up green. So that's when you release the your mouse button. Then you can content knowledge, pedagogic knowledge will be also direct like this. Pedagogic content knowledge will be direct like this. We can say we'll have something direct from content knowledge to pedagogic knowledge, and then from here to there, and it goes on like that, I reckon. So sex, let's look at some direct path here, and then resources, look at it, direct path to resources. I want to hypothesize that content knowledge will have a mediating effect through resources to teacher performance. Welfare directly like this too. So this is a hypothesized, path. By the time we do the analysis, things will be straightened out. Now, what's the next thing? Yeah, next thing, maybe I want to hypothesize that welfare and sex will have some variation like that. So we have the arrow. Let us now add the error terms to all these variables that are being taken as dependent to which arrows are pointed. So you look at this, draw unobserved variables. So we'll click on this, and then we'll draw an observed variable here in the form of a circle, and you double click on it so that you can give it a variable name. Usually we use E for E. So this is our first E, you say E1. If you notice there is no OK button on this dialog box, you can see it's already written here. So all you need to do is just close it like this, and then put an arrow to connect from this E to that. What else? This is also pointing to this, so this will need to have an arrow. You double click and it gives what? You write E2. So you close this and then you draw an arrow here up to there. So we're going to do the rest very quickly. Next thing, of course, is to now click on each of these arrows and assign a weight of 1. You click on this arrow here, and then the parameters that you have is so we'll give it a regression weight of 1. Okay, no OK button here too, so you just click on it. You can see that the 1 is already there. You do the same thing for here, regression weight of 1. You close this. Yeah, our hypothesized model is now complete. Do you think it's complete? Of course not. You will notice that the resources is now serving as a dependent variable for CT, content knowledge, and this is also serving as this. So we should put some error terms here. I'm not going to do that yet, and you'll see what error message AMOS is going to give to us when we do the analysis. Yeah, we're almost there. Before we do the analysis, we got to indicate the analysis properties. So you click on this. Now, the estimation maximum likelihood, yes. You recall that at the beginning of this lesson, we looked at all of this that AMOS is capable of doing. Now, what about the output? It's giving us as default minimization history. Good for us. Let's do standardized estimates, squared multiple correlations, sample moments. Here we can have the indirect part, indirect, direct, and total effects. Factor, score, covariance, estimates. Yeah, so that's fine. Now, let's now run the analysis, which is this one. Calculate estimates. Okay, I'm clicking on this now, and it's flagging an error. You know, I mentioned to you that look at this. The following variables are endogenous, but have no residual error variables. Look at resources and PCK. So we've got to do that before we conduct this analysis. It's telling us here again that AMOS will require the following pairs of variables to be uncorrelated. Well, we don't have any control over this. Let's cancel this analysis and then proceed to add the error thing. How do we go? Click on this and then put this one here. So that will be, we have error 1, error 2, this error 3. We double click on it. Yeah, we go to the text. This is E3. That's it. I'm going to do the rest. So as you can see, I've done error 4 too, and I've put the estimates there. So we're all set to go. What next? We will click on calculate estimates. Of course, it's giving us this error. That doesn't. Let's just ask it to proceed with the analysis. So it's going to save the input file. Let's give it a name. We'll call this one sample 2. So we'll call the data sample 2. So let's call this one sample 2. And we'll say save. So you can see it has done it at the background. It has given us all these values. We'll be looking at the tables that it will generate for us in the next lesson. So, okay, let's just have a quick look here. So these are some of the tables that it generates for us. And from these tables, we have all the beta weights added. If we go to the standardized estimates, if you click on standardized estimates, on the left here, this toolbar gives you the hypothetical model. The right one gives you the final output. You can see, view the output path diagram. If I click on this, you will now see, come on here, the different beta weights, regression coefficient. coefficients. So you can see from here, content knowledge 0.24 beta on this. Pedagogic knowledge 0.28, pedagogic content knowledge 0.34, and resources 0.57 to teacher performance. Content knowledge content knowledge is 0.04, pedagogic content knowledge 0.34. These are the these are the beta with spark coefficients to teacher performance. We'll be looking at fuller details of this, fuller interpretation of this in the next lesson. So what then do we need to do? You need this output, look at it, the output pie diagram. You need it in your report, in the file, maybe Microsoft Word file where you are writing your report. So what then do you need to do? AMOS provides a very easy tool. You click on this, you can see copy the pie diagram to the clipboard. When you click on this entire pie diagram is already taken to the clipboard. Let's now go to Word. Let's have a new Word file. And then if you right click, I do Control V, you right click and say paste. So that is it. Very, very easy. Very, very beautiful. So that is the end of the lesson on how we use AMOS. And in the next lesson, of course, we shall be looking at how we do the interpretation. So are we now all fairly comfortable with the use of AMOS?
Yes, sir.
Okay, yeah, very comfortable. Okay, fine. So if you are comfortable with it, you then need to apply AMOS on the same set of data that you applied your multiple regression analysis to get the pattern analysis. So let us see how the two compare. Until next session, next meeting. Okay, it's bye from us in Lagos.